Hello, everyone. This is Mix K. Today I'm going to be going over how to do the atomic numbers for the most abundant neutral atoms. So let's first break down what this means. Most abundant means the most common of those atoms. Oh, shush, Ledger, it's fine. Okay, so if it's the most abundant, it's the most common form of that atom. If it is neutral, that means that it has no charge. So if there is no charge, all the positives and all the negatives need to cancel out. So atoms of an element that is the most common on Earth and its overall charge is 0. An atom's identity is determined by the number of protons. So if an element has this, or if you have the same element, it's going to have the same number of protons. So we call this number something very special. We call it the atomic number. The atomic number is just the number of protons. And it gets a special name because it's what tells us what kind of element we have. So for example, carbon has an atomic number of 6. It is always going to have 6 protons, no matter what. Now, because we want our atom to be neutral, we need the positives and the negatives to cancel out. Let me just open up a Jamboard real quick so I can draw and show you what I mean. New one. Okay. So if we have positive and negative charges, they work kind of like how positive and negative numbers work. So if you have plus 2, positive 2, plus negative 2, you're going to end up with 0. The 2 positive charges cancel out the 2 negative charges, and we end up with 0. So this would be like if we had 2 protons and 2 electrons, their charges are going to cancel out and equal 0. Okay? So when we have a neutral atom, we want to have the protons and the electrons equal to each other. So this atomic number at the top tells us the number of protons, and if the atom is neutral, it also tells us the number of electrons. We have another number on our periodic table. It is called the mass number, and it's going to be a decimal number at the bottom. Your atomic number is at the top, and it's always a whole number. The mass number is at the bottom usually, and it's usually a decimal number. Now, the reason it's a decimal is because it's actually an average. So this is an average of all of the masses of every carbon atom there is. So we took all of the carbon atoms and we figured out what their average mass was. Now, what this means, because it's an average, what we can actually do is if we round this to a whole number, the closest whole number, we're going to get the mass of the most abundant atom. The one that's the most common is going to make the average be closest to its value. It's kind of like if you have a bunch of A's in class, your average is going to be closer to an A, even if you got one F, right? So our average here is closest to the most common mass. So we have our atomic number at the top. That tells us the number of protons and electrons in a neutral atom. We have the mass number at the bottom that we round to a whole number. Now, when we round in this class, what we're going to do is we are going to follow the very simple rounding rules. We're not going to do anything too complicated. So for us, if the number, let's just say we have 5.4. If this number after the decimal is 4 or less, we round down. Okay, so if I round down, this is going to become 5. It's closer to 5 than it is to 6, so we round down. But let's say you had 5.5. If your number after the decimal is 5 or more, you're going to round up. So if I round this up, I'm going to round it up to 6. Okay? So 0.4 or lower, we round down. 0.5 or higher, we round up. Now, there are more complex rounding rules. We're not going to worry about them too much in this class. For us, this will be good enough for us to do our rounding, but just know that there are more complex rules. Okay, now the only other thing we need to talk about with the mass number is how we find the number of neutrons. So we've talked a little bit, just a little bit, about how mass equals protons plus neutrons. So we know how to find the number of protons. We know how to find the mass. So if we rearrange this equation, we can figure out how to find the number of neutrons. So let's say I have mass equals protons plus neutrons. Okay. If I rearrange this, I subtract protons on both sides, and I end up with mass, this cancels out, minus protons equals neutrons. Okay, let me write that one more time. Mass minus protons equals neutrons. So we can find the number of neutrons just by subtracting the protons from the mass. So now we've talked all about these different numbers. I did forget to mention the atomic number we abbreviate with the letter Z. It's just how it is. I know it doesn't match, but that's what the abbreviation is. So our atomic number is a whole number at the top. It tells us the number of protons in any atom. And if the atom is neutral, it also tells us the number of electrons. The mass is a decimal number, usually at the bottom. You're going to round this to a whole number to get your mass. To get the number of neutrons, we do mass minus protons equals neutrons. Okay? So let's do an example. So I drew the little box up the top here, so we don't have to switch to the periodic table yet. But first, we want the atomic number. So the atomic number is the number at the top. Hold on, I think my formatting got messed up, so just give me one moment. Okay, that should be better. Let me just do this real quick, guys. Don't worry about what I'm doing. It's just my formatting got messed up. Okay, there we go. So our atomic number for carbon is up at the top. It's going to be 6. Now, we talked about our protons are going to equal the atomic number, so they're going to be the same. They're the same exact thing, so they should always be the same. Our electrons in a neutral atom are going to equal the protons, so this one will always also equal 6. So our atomic number, proton, and electrons are the same. Now we're going to look at this bottom number to get our mass and round it to a whole number. So we have 0.0, so I'm going to round down to 12. To get my neutrons, I'm going to do mass minus protons equals neutrons. Now, just for your own information, sometimes our neutrons are going to equal our protons and our electrons. Sometimes they're not. It just depends. So this time they all happen to be the same. They won't always be the same. So make sure to find your neutrons. You do mass minus protons equals neutrons. Okay, I'm going to go over a few more examples. Feel free to pause as I go. Try the example out on your own, and then unpause to get the answer. So you do need to use your periodic table. I have attached it in this file if you need it. But I'm going to click over to mine over here. Actually, no, I can just go down here. So our first element is hydrogen. So for hydrogen, I can see that there's a 1 at the top, so that's my atomic number. and 1.01 at the bottom. So that's my mass. Whoop. So, there we go. So my atomic number for hydrogen was 1. So my protons and my electrons are also going to equal 1. My mass at the bottom was 1.01. So I want to round this to a whole number. So when I round this, I have 0.0. So I'm going to round down to just 1. To find my neutrons, I do mass minus protons equals 0 neutrons. Okay, let's take a look at helium. Okay, helium is right over here. We can see its atomic number is 2. It's the whole number. And its mass is 4.00. Okay, so my atomic number is going to be 2. My protons are going to be equal to my atomic number, so that will also be 2. And because we have a neutral atom, the electrons and protons will be equal. Our mass was 4.00, so we can round that down to 4. And to find my neutrons, I do mass minus protons equals 2 neutrons. Okay, so lithium, we have the atomic numbers at the top, it's 3. The bottom, we see the mass is 6.94. So my atomic number is 3. And you're going to see this is getting repetitive, but it's going to get stuck in your head. My atomic number is 3. So my protons are going to equal 3. And because this is a neutral atom, we want the positives and negative charges to cancel out. Their electrons will also be 3. Our mass was 6.94. Now, if we look at this number, it's 0.9, so that's 0.5 or higher, so we round up. Think about if you were looking at the price of something in the store, you're going to round this up to 7 in your head. So 0.9, we round up to 7. To get my neutrons, I'm going to do mass minus protons equals 4 neutrons. Okay? Beryllium, its atomic number is 4 at the top. Its mass is 9.01. Okay, so its atomic number is 4. Its protons are going to equal 4. And its electrons are going to equal 4. The mass was 9.01. We can round that down to 9. So mass minus protons equals 5 neutrons. Okay, last one. Boron. Boron has an atomic number of 5 and a mass of 10.81. So its atomic number is 5, so its protons will be 5. And in a neutral atom, the positives and negatives need to cancel out, so our electrons need to be 5. So there's 5 negatives and 5 positives, and they cancel out to 0, neutral. Our mass was 10.81. So this is 0.5 or higher, so we're going to round that up to 11. Mass minus protons equals 6 neutrons. Okay, so that was a bunch of examples. In the next video, I will go over how to do ions and isotopes, and I hope that you guys have a lovely day.